On part two, we are now talking about our phase shift, our C. Okay, your phase shift is your horizontal translation. Okay, it's what's causing your function go left and then go right. All right, when you are doing your phase shift, it's going to be something on the inside that says plus or minus a C value. Does that make sense? Okay. In AP Pre-Cal, they wanted us to teach you it as a positive and let you know that C is negative, which is annoying to teach. So I'm not going to teach it, but I did want you to see how I'm supposed to show it. We're going to continue to think of it as our C's being what? Liars. Okay. So for us, we're going to see it as G of X equals sine of X minus C. And C is whatever it is. C is a positive or a negative because X's are liars. It's going to be always the opposite of what it is. It just makes it easier and less complicated to view it that way. If that's how you've been taught for the past 2 years, in my opinion. But they did want us to teach you it as to multiply the C value by a negative, which just seems like more work than just remembering it's a liar. Okay, but I did show you and I did do that, so it is what it is. But we're going to stick to X's are liars and move on with it. Okay, so when you're looking at a phase shift, typically with a phase shift, we are starting off without changing the period. Does that make sense? So we're not changing the length of the period. The period is still 2 pi as of right now. We're just making sure we can see that we've moved. How far from the origin did we move? Does that make sense? That's what you're gauging, is how far from the origin did you move? All right. Because of this, there's always multiple answers to this. Okay. There's going to be multiple answers that could be the possible one. And that's because whether you're looking at it as a cosine or a sine graph is going to be important. All right. So when we look up here, if I look at this as a cosine, as a cup function, I can see that this is where a positive cosine function starts, right? So the positive cosine function, highlight, starts here. Do we see that? How far removed from the origin is this value? Pi. It is 1 pi far removed. Does that make sense? I move 1 pi unit to the right. Okay, which means that it will look like minus pi. The problem with this one is that it puts me at a negative cosine. Am I looking at it as a negative cosine? No, I'm not looking at it as a negative cosine. I'm looking at it as a positive cosine. So that is why it would not be that cosine model. Does that make sense? Okay, this guy right here is saying that you didn't move at all. Okay, you did not move from the origin, which would be cool if it had a negative in the front. If this one had a negative in front, I didn't move from the origin. I'm just a negative, but there's no negative in the front. Does that make sense? You see the differences to why we're not looking at it from the cosine perspective. Yes? All right, so we wouldn't choose either one of these because of that reason. Yes? All right. Now, let's look at the sine options. Looking at the sine options, this one is telling us that we went to the left pi over 2. So our sine function shifted to the left pi over 2, which it could. I just don't see that at this moment, right? Just because I don't see it doesn't mean it did not happen. But if we're looking at it from a sine function, this is our sine from here. So what I can see, this is my sine function, okay? And sine functions have that rotational symmetry, correct? So they're going to be doing the opposite of what's on the other side. All right, so if this side I'm at negative 1 over pi over 2, on the other side, I would be at pi over 2, negative 1. On the other side, I would be at negative pi over 2, positive 1. Does that make sense? Because it's doing the opposite on the other side because it's of that symmetry. Oh, if I was going through the origin, that was terrible. Don't listen to that part. But you can see this moving transformation, okay? The other thing that you can note here is if you look at the 3 pi over 2, 3 pi over 2 is all the way right here. If I come to 3 pi over 2, do we see how it makes a negative sign? It completes it out. I can't measure this one, but I can measure 3 pi over 2 using the graph that's given. So if I come here, it starts here, goes up, comes back down at my midline. Is it negative? Did I move to the right 3 pi over 2? And is my midline at negative 1? So therefore, the correct answer would be D. Okay? They're expecting you to pay attention to all of those small details when you are selecting. Bless you. All of these types of questions are going to be on the non-calculator side. And the reason why it's on the non-calculator is to make sure that you have the understanding of what the function is doing, what each transformation means. So you won't have the luxury of checking in a calculator to see and matching. That's not an option. So you go piece by piece and analyze what they're saying. If I can't see it, is that what I have? Okay. All right. So let's try. This one's a little different. So if you look right here, well, let's try yet. I'm not letting you free. This is another example. This time we have all of our functions in play, all of our variables. We have A, B, C, and D. So what I want you to note is that what does that look like as a function? So when you have all of them at once, so for cosine, you would have A, cosine. Notice that the B has to be factored out. Your leading coefficient has to be factored out, which means that in order to figure out exactly how much it shuffled or shifted, you would have to factor it back in to see where it's starting. Because yes, you have this phase shift, and then after you phase shift, you then compress it, right? Because we do PEMDAS, and PEMDAS says we do the parentheses first, and then we multiply, right? Same thing here. We would do the shift, and then we would multiply. So what would happen after I did that? So here, if I have x is pi over 4, so I'm going to shift to the right, pi over 4, correct? After I shift to the right, pi over 4, what's happening to that x value? It's being compressed, right? So if I'm being compressed, that means I am dividing this by 2. So actually, it's going to look like I'm at pi over 8 is where it's going to ultimately end up at. Okay? If that doesn't make sense, then let's try it again. So starting off here, cosine. We're going to look at it as a cosine function. My first cosine function starts right here. Okay? This is showing that cosine was shifted and compressed it. Pi over 2. Yes? Do we see that? So when I'm shifted and compressed it here, I can see that this is at pi, and then I need to divide it by 2. Which one of these would show that cosine being compressed, shifted, and then compressed by 2? So shifted, pi units, then divided by 2. Anyone? So you're describing the function. You know that it's shifted, and then it's divided. It's compressed. All of them have 2. All of them have it. So I'm going to give you a moment to think about it. Now I'm going to tell you what the answer is, but I want you to think about it. Because if you're waiting for me to tell you, I'm not going to see. Did anyone notice a shortcut or possible? Well, let's talk about it. I just realized what time it was, and no one was going to tell me. Yeah, I didn't realize it was 40. Okay, so pi over 4 is our starting point. If I go to pi over 4, where's pi over 4 located? Between 0 and pi over 2, right? So between 0 and pi over 2, I start here, and this actually creates a what kind of curve? Sine. So does that work for this one? No. If I go to pi, pi's right here, and pi creates what? A negative cosine. Is this a negative cosine? No, it doesn't work. I go back to pi over 4. Okay. Does that work so far? Looking plausible. Okay. Next, did my period get chopped? Did I go from a whole period, from 2 periods to 1 period? Yeah, that's a half and a half makes a whole. And is my midline at 1? And is my amplitude at 2? So okay, work from the inside out. Just like PEMDAS tells you, we start with the innermost parenthesis. So looking for that starting point and working our way out. All right, and then do we have one left? Yeah, let's see if we can squeeze her in. All right, on this one, this goes back to our FRQ that we're all going to thrive and do excellent at, right? We're going to kill this FRQ. I believe in us. So it says here that the coordinates are given. We have 2, 16. So we know F is 2, 16. We know that G is 5, 11. We know that J is 8, 6. We know that K is 11, 11. And we know that P is 14, 16. Do I have enough information to be able to write the function? We do, right? And it wants us to write it as a sine function. Because it wants us to write it as a sine function, as a positive sine function, we have a couple options of where we start. If we're writing it as a positive sine function, I would go ahead and say, this is a positive sine function. This is a positive sine function. Does that make sense? And you're counting the pattern in between. We know that there's a 3-unit change in between each one of them. Does that make sense? So if there's a 3-unit change, what is 2 minus